Welcome back. In this part of the lecture video, we are going to check out how to implement regression using R, particularly the OLS estimator, how to implement those OLS estimator in R. So now we are going to look into this R. We are going to open an R script. And one good thing about R is this empty cars data set is already available in R. So you just say empty cars and run this. As if here is a run, I can just put a run there, and then if I just say empty cars, then and run it, so I will get all the data here. You can see miles per gallon, cylinder, displacement, horsepower, all these variables, and there are 32 models. For each models we have the specifications. Now let me clean the console. Now what we want is we want to keep miles per gallon in the y vector. So before do that, let's pick this, put this things tickers, and then let's call it mpg. So we can just look into the call names of empty cars. So this is the mpg. I can look it up here and run this, and if I run this, so these are all variables are there in the y variable. And then what I can do, so now what I will do, I will bring predictor's name, predictor name, and maybe horsepower, weight, and displacement, DIS. Yeah. And then we can just write empty cars as with predictor names here. So we have this capital X, the design matrix. Sorry, we will take it as a small x. And sorry, I need to run this on the thing. And now I got this 3 variables here, but remember that these are still at a data frame structure. So if we just say structure x, you see it's calling data.frame. So this is still at a data frame, so we have to convert it into a matrix. Before that, what we have to do, remember that we have to add a intercept here. Okay, so we'll define intercept as replicate 1, n, but I don't know what is n. So before that, we have to say n column of empty cars and n row of empty cars is 32. So we will put that in n. So n has 32. So now if I just run this, so I have intercept as 1, and now what I will do, cbind the int and this will give me the thing that I'm looking for. So, and we can put it into x as dot matrix. So now we have x as matrix, and if we just say here structure of x, it's a numeric array with 32 rows and 44 columns. It has dimension names. The list in the rows, these are the dimension names, and in columns you have these three columns: intercept, horsepower, weight, and displacement. Now my data is ready, both x and y is ready. So what we can do first, calculate. So in x transpose x. So first thing I will do, I will say p of x. So now we can see this is transpose of x, and then I will multiply. In the matrix multiplication in R is percentage star percentage. So if I just do that, it gives me x transpose x, and then what I will do, let me just put it in xt times x. Let me define this variable xdx times x. So this is x transpose x, and then solve that. X inverse of xdx will be, basically you solve this x transpose x. This will give you calculate x transpose x inverse of x transpose x. So this will give you the x transpose x inverse, and then you calculate beta x transpose x inverse percentage star percentage x transpose percentage star percentage y. So if I just run that, so this is the values that I'm getting. So this is, I'm calling it beta hat. So if I just run this, so this is my beta hat. And now what I'm going to do is going to call, there is a something called lm. If you just go to console to question mark lm, it will open the manual for lm. It fits the linear models. So what model fit linear regression using lm? The model I want to fit is miles per gallon as a function of intercept plus v1 times what was there, horsepower plus v2 times weight and displacement, weight, and v3 times displacement, and plus some error. Okay, so this is the model I'm trying to fit. So what I will do is fit equal to lm, you have to say miles per gallon tilde horsepower plus weight plus displacement, comma. Now data, you have to provide the data is empty cars. And now if you just run this, that is good enough, so no. And then if you just say coef equal to fit, it will give you all the coefficient values that you are looking for. Now what we will do, we will just c bind them again beta hat and cbind them. Now the first one is coming from uh, the R's LM models. You can blindly apply the R LM models, and this is the second one is beta add. We calculated all by ourselves, and you can see these two values are matching till the last digit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till 10 digit. Both the method are matching exactly. So this is how LM or in both in R and Python they are calculate the coefficient values through this matrix operation. I just showed you that how to do that. Next, I want you to learn few things. Uh, so suppose you want to, before fitting a model, probably you'd like to plot some of the, you know, uh, some of the data that you have um, to develop an intuition. So maybe we want to plot horsepower and empty cars, dollar miles per gallon. And if we just plot that, so we get this kind of plot. If we just put say PCH equal to 20, you can and run again, you will see this now plots are kind of filled up with the black. It's like more prominent. But you see the way we have provided the code, that okay, from the empty curves you extract the horsepower and that will be your x-axis, and empty curves you extract the miles per gallon, that will be your y-axis. We don't want to see it in this way. Maybe we just want to give a name for this. X lab equal to the label stands for labels horsepower, and y level equal to miles per gallon. Miles per gallon. So now if we run, you can see that labels are now look nice. And then what I'm going to do, I'm going to call a function called AB line, and in that AB line I'm going to call LM, which is a miles per gallon as a function of horsepower, and I have to provide the data equal to empty cars, and I have to provide a color. I will provide a, maybe I will provide red color, and if I do that, you can see it's drawing a straight line here. So maybe what I will do, I will just increase the line width to 3 maybe, and now it's a little bit better. If you increase, if you may consider LTY equal to maybe 1 or 2, and if you just on this, this might be okay, maybe 2. So now you can create a dash line. If you choose line type equal to 2, 3, 4, this will give you different kind of dashed line. And last one thing, if you want to do some grid, if you just say grid with color equal to maybe gray, and you run this, so you will see that there will be a grid kind of thing comes in. So a lot of things you can do with these kind of plots, and these kind of plots are very useful in linear regression. Now I'm going to show a few more things, like a little bit more on the exploration of the design matrix. So if we look into this data set, empty curves a little bit more, okay? empty cars dataset. Maybe we just say head. So we see that cylinder is typically 6 cylinder, 4 cylinder, or 8 cylinder kind of things, and then you know, VS is V-shaped or not. AIM stands for it's automatic car or manual car. Gear stands for whether it's a 3 gear car or 4 gear car, and carburetor stands for how many carburetors they have. So suppose, and so far our regression model that we have discussed are all in our um, predictors are all essentially continuous variable like horsepower or weight or displacement. They, you can consider them as or continuous variable. But what happens if my predictors are not continuous variable, rather my variables, these are all categorical variable. So let's see how these things happen. So first let's work with the cylinder. It could be 6 cylinder, 4 cylinder, or 8 cylinder. This cylinder is a ordinal categorical variable. You cannot have a 5 cylinder. Generally you don't have a 5 or 4 cylinder car or 5.5 cylinder car. You can have a 5, you may design a 5 cylinder car, but you cannot have really 5.5 cylinder cars. So it's a sort of a discrete kind of things. And how, and if you want to give them as a categorical variable, you want to, if your predictor has a categorical variable, how you handle categorical variable in the linear model setup or the in the design matrix. Now how do you do that? So the one good thing is, one possibility is, you just in the if you look into the structure of the data set, empty cars, here cylinder is being coded as numeric variable. So but what we will do, we will transform them it into factor variable. So now what I will do, I will just take it as empty cars dollar cylinder as dot factor empty cars dollar cylinder. Now what is happening, if you look into the structure of the data set, you see a factor, and it has 3 levels, 4, 6 and 8. Now what we will do, we will if we run the LM between say miles per gallon and say cylinder, then it is called data equal to empty cars, and we call it fit to, and then if we run say summary of it, so what we will see that for 6 cylinder we got something, and for 8 cylinder, and then there is an intercept. So what kind of, we will try to understand what kind of model R is fitting here. So you have to first understand how the data set is. So what we will do now, we will go back to the theory and we will try to understand how to handle this kind of categorical variable as predictor. Thank you. Let's continue on the next video on the theory side of how to handle categorical variable in the predictor.